Okay, so now let me show you how to use the calculator to calculate a binomial probability with the built-in function. So there are two binomial probability functions in the calculator. And depending on what we want to find, that's how we know which one to use. And I'm going to cover both. So we can use the built-in functions in our TI-8384 calculator. And the way we get there, and I'm going to do it with you in a minute using my calculator, I'll share my screen. We press second and we're going to go into distributions and we're going to find binom PDF, or depending if what we're solving for, we might want to go into that same menu, second distributions, but we might choose binom CDF. So you're going to see that they look very similar. The difference is going to be one is called binom PDF and the other one's binom CDF. They stand for binomial, with the P stands for binomial probability distribution function. And then binom CDF stands for binomial cumulative distribution function. So here's the difference. We use binom PDF when we want to calculate the probability of getting exactly S successes. And we would use the cumulative function binom CDF if we want to calculate the probability of getting at most S successes. It's a cumulative probability, so it's going to add up the probabilities that are included in at most S successes. And you're going to see the difference between the two of them. So why don't we do this? Let's go back to the problem that we did in the last lecture, the one where we tossed the coin 2 times, and I wanted to know the probability of getting exactly 2 tails, and then the probability of getting at most 1 tail. So we've already done it 2 ways, right? We did it using a list of all the probabilities, and we calculated the probabilities by hand using the sample space. And then the second way that we did it, because we realized that tossing the coin twice was a binomial experiment, I showed you how to use the binomial formula. But now what's nice about the TI-8384 calculator is that this binomial formula is built into the calculator. We just have to tell the calculator what parameters to use. So let's do this. Before we get into example 10, let's use the calculator to redo this question a third time, but now using the function in the calculator. So we're going to toss a coin 2 times. And A, we want to know what's the probability of getting 2 tails, right? Exactly 2 tails. And then B is what's the probability of getting at most 1 tail. So we'll do that after. Let's do part A first. So remember, binomial formula for S successes is going to be N choose S times P to the S times Q to the N minus S. Now you have to know what N, P, S, and Q are in order to use the function in the calculator. So we'll redo this. I know we did this in the last video, but let's just make sure, we're okay with this. So N stands for the number of trials. So how many times are you performing this procedure, right? We're tossing the coin twice. So N is equal to 2. And we're interested in how many successes, where tail is being considered a success, right? So in part A, we wanted 2 successes. So we're calculating the probability that S equals 2. Now, P, the probability of a success or a probability of getting a tail on any one trial is 0.5. And then Q is equal to 1 minus P, or 1 minus 0.5, which is also 0.5. And that's the probability of failure, basically getting a head instead of a tail. So now I want to use the calculator to find this answer. So we're going to use the calculator to find the probability that S is 2, that there's 2 successes. So let me share my calculator screen. So actually, before we go to the calculator screen, let me just point out that this is the formula that your calculator is going to use. It's already built in. We just have to tell the calculator how many trials there are, what's the probability of a success, and how many successes are we trying to calculate. So we have to go to distributions. And remember, I already have these steps highlighted in yellow in the Word document. So second, and then your distributions. So it's the VARS key, VARS, and blue above it, you see distributions, and this is a binomial distribution. And since we're calculating exactly two successes, we're going to use binom PDF, which is option A. So if you scroll down, it's option A, binom PDF. And the calculator tells you exactly what you need to enter. So how many trials are there? And we wrote that down, right? So we said there was 2. N is equal to 2. What's the probability of a success, meaning getting a tail on any given roll? It's 0.5. And the calculator uses X value instead of S value, but the X in this case means successes. So you have to tell the calculator how many successes, the probability of how many successes are we trying to calculate, and S was 2 in this case. And then we paste, and then we hit enter. So we're going to hit enter twice, and we get 0.25, which is exactly what we got when we used the binomial formula by hand, right? This is so much quicker than having to plug into the binomial formula. We're just telling the calculator to do it for us, right? So this was equal to 0.25. And now B is what's the probability of getting at most 2 tails? So whenever we're going to calculate at most, remember, it means not exactly 2, it means at most 2. And I'm sorry, I think it should be 1 tail, right? The question said at most 1 tail. What does that include? That includes 0 tails or 1 tail, right? So whenever we're going to use the at most function, that's going to be binom CDF. So that's when we use binom CDF. If we're going to calculate exact, like we did in the previous one, this one was binom PDF. So that's for exactly S successes. In this case, we use binom CDF for at most S successes. So in this case, N is still 2 because we're tossing the coin twice. But now S is going to stand for at most, right? How many successes? So this is going to be at most 1. So we're going to use 1 for that value. And then P is still equal to 0.5 and Q is still equal to 0.5. So now we're going to pull up the binom CDF function. So second, and then the VARS key to pull up our distributions. And we're going to scroll down. Now we want to use binom CDF because it's not exact, it's at most. So we want it to make the cumulative probability where it's going to add up 0 plus 1 successes for us. So we're choosing binom CDF. So it's still going to ask for the same things. How many trials are you performing? So 2 flips of the coin, right? What's the probability of getting a tail? It's 0.5, right? That's the probability of a success. Now remember, the X value is the number of successes. It's S in our formula, but the calculator uses X. So since this is at most now, put the number for at most, right? So in this case, we want at most 1, and now we can paste and then hit enter. And you see how it gives us 0.75? We don't have to add them up 2 separate times like we did when we used the formula by hand. The calculator does it so quick and adds it together for us. So this is very convenient to use this function in the calculator to solve binomial probabilities. Now going forward, any binomial probability distribution examples that we do, I'm going to use binom PDF or CDF in the calculator. So let's just write this down. So this was equal to 0.75, which we knew from the other 2 times we did it, right? But it matches up. So let's just do one more example in this lecture. Let's do the next one, which is example 10. So example 10 says, assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability of exactly 2 boys in 10 births. So I'm reading this and I'm thinking, okay, we want the probability of exactly 2 boys when there's 10 births altogether. Now, this is reminding me of a binomial experiment. Remember those 4 conditions that have to be satisfied? The first one being there's only 2 possible categories, right? So when a child is born, it's either male or female. There's that bi, too. So there's 2 possible outcomes, male and female, right? Now, how many trials are there, right? How many births are we examining? So in this case, there's 10 trials or 10 births. And it says explicitly here, they're all independent of one another. Because remember, that was the other criteria, the third criteria, that these trials have to be independent, meaning that the birth of any one child doesn't affect the probability of the gender of any other children. So, for example, if a boy is born first, that's not going to influence the probability of a boy or a girl on the second trial. They're all independent. And the probability of a success stays the same for every single trial. Now, think about what we're interested in this case. We're interested in, out of the 2 possibilities, right? We have boys and girls. We're focusing on a success being a boy, right? Because that's what we're talking about, boys. So, what's the probability in any single trial or any single birth that a boy is going to be born? It's 1/2, right? Because you have a 50% chance it's going to be a boy or a 50% chance it's going to be a girl. So for any given trial, the probability of a boy is 0.5 or 1/2, and that stays the same for every single trial. So those 4 conditions are satisfied, and that's why this is an example of a binomial experiment. So we could think of this as finding the probability that S, the number of successes, is equal to 2, because we're considering having a boy a success, right? So let's think about the parameters now. So before we plug into the calculator, we need to know N, P, and S, right? So the question is, how many trials are there, right? How many births are we examining? So in this case, there's going to be 10 births or 10 trials. We said that a success is being a boy, right? And what is the probability of being a boy? What's the probability of a success, right? So the probability of being a boy for any given birth is 0.5. And now for this one, what are we trying to find the probability of? We're trying to find the probability of exactly 2 boys or exactly 2 successes, right? That's what we're looking for. The probability that the number of successes is 2. So S is equal to 2 in this case. Now we can go to the calculator because we could choose binom. This is going to be an example of binom PDF. Remember, we use PDF when we're calculating an exact amount of successes, which is 2 in this case. So N is 10, P is 0.5, the number of successes is 2. So now we could go and plug this into the calculator. So we're going to pull up binom PDF, so second and then the varus key to pull up our distributions. We're going to scroll down to A, which is binom PDF. So there's 10 trials, N is 10, right? 10 births. P, the probability of a success or having a boy on any one birth is 1/2 or 0.5. And remember, the X value is how many successes are we interested in calculating? And it's 2, right? We're trying to find the probability that the number of boys is exactly 2. So that's the X value. And then we paste and then press enter. And let's go 4 places. So to 4 places, the probability is about 0.0439. So if we were to examine 10 births, the probability that there's going to be exactly 2 boys out of those 10 births is about 0.0439, or about 4%, a little more than 4%, right? About 4.39%. So I'm going to stop this lecture here. And we have 2 more examples. We have example 11 and example 12, and I'll do those in the last lecture for this chapter.